group because I know it might have been a while since you've done these. So anyways, there's a little review. There's some, what is that? Pre-algebra right there, review.
Yes.
Any questions on this before we go to groups, and I'll give you some problems to start practicing?
It's not so much a question on this. The pay for the work that we have to do today, when I printed it out, it says 2 through 5.
2 through 5.
Like the page number. I just want to make sure because that's the same thing I had.
Oh, maybe it just doesn't have page 1. Yeah, it looks like there's no page 1 on it for some reason. That's weird.
No, yes.
The page 1 looks like it was kind of blank. Maybe it got messed up.
Okay, I was just double checking because that's the same thing earlier.
Yeah.
I want to make sure I put out the right stuff.
Okay. All right, any other questions before we go to groups? No? Okay, so let's go practice some square roots. So we have number 1 is practice, number 5 is practice, 23A, 25A. Let's do that, and then let's go. I feel like y'all could do a bunch of these because they're kind of fast. Like faster than some of the other stuff we've been doing, like graphing and all that stuff. That stuff was quite a bit longer. These are a lot quicker. So let's do those ones that I typed in the chat, which is basically most of the first assignment.
Is 49 supposed to be extended all the way, or is it just?
Yeah, 49 looks a little weird. So just to be mathematically correct, let's just extend it. Because I can't tell, so let's just extend it for the sake of us doing this problem. That technically the bar should be clear about whether or not it's over the variable. So on 49, I'm just going to extend it. Okay. So that way it's very clear that the b squared is under.
Yeah, I think I said it in the notes, but that's usually why we write things in front of the square, not after, like our variables and stuff.
Yeah, or we might write like a times. So if we want to do like square root of 3 times b, I mean, really it should be the b in front, but anyways. So yeah, let's do those problems. I think that's a good amount of practice since they are a little bit quicker than some of the other things we've done. So let's go to groups.
And then I just put minus out because with the the imaginary number, it's down when I saw the lecture notes, but it's okay. And the square of 100 is 10, which it's going to be 10i.
Okay. So real quick, remember the I is when the negative is on the inside. On this problem, the negative is on the outside.
No, sorry. I think it's just minus 10.
Good. Yeah, it's just negative 10. No, it's okay. So remember that the I is when you have a negative inside. Remember when you put in your calculator square root of negative 100, you get an error. That's when we're using the I.
It's not squared.
No, it's not.
It's not in the square root. No, the negative is outside the square root. So if you were to type that in your calculator, like if you type in negative square root 100 equals in your calculator, it will work. There's no problem there. We don't need any I's. We don't need any complex numbers. Yeah. So that one's just negative 10.
Yes, it did minus 10. I don't know where I came with I.
Okay. All right. 5A, Kayla, you're next in group 1.
So I got the square root of 2 times 2 over 3 times 3.
Okay.
And then the square root of 2/3 times 2/3.
Okay.
And then I got 2/3.
Okay, cool. Yeah, so the 2's got to go out and the 3's got to go out. Yep, cool. Sounds good. Any questions so far?
It's not so much of a question on our work, but like, okay, for 1A, you know how you have, the square root of 64 equals the square root of 8 times 8 equals 8, do you, like on our work, do you want us to write all of that out?
No, no, you don't have to.
Okay.
I was just showing it because that's what was said by the student that was explaining it for both of those, so I wrote it out.
No, okay, yeah, no, I'm just trying to double check. So for when we do a test or when we do our, you know, our homework and stuff, because you know, off the top of your head, you know, the square root of 64 is 8. Can I just put 8 in?
Yeah.
Okay.
Yeah, yeah. Now, if it's something like the square root of like 1,254,000, I would be like, okay, maybe I need to see what you broke down. But if it's like square root of 64, I mean, that's just 8. So it's fine. Yeah. Okay, 5B, next is Sage. Did you start this one at all, Sage? Sage, are you here? Sage? All right, I'll call on Sage again in a minute. If they're still not here, then we gotta take them out. Okay, out of class. Next would be Diana. Diana, did you get this one? Are you here?
I skipped over this one.
You skipped over this one. Okay, did anybody get this one?
Yes.
Okay.
-1/10.
Ooh, okay, how'd you get -1/10, Michael?
Kind of on the same principle as 1B in that it's more or less just, whereas the first one went down a decimal place, this one was going up a decimal place, with the tenths being the step offs.
Oh. So you thought of it as like 0.1 times 0.1?
Yes.
Okay, okay, yeah, you could think of it that way as well. So you could also think of it as -0.1 times 0.1, like that, the negative outside. Another way, if you're more familiar with fractions, is you could make it into a fraction. So you could have the square root of 1/100. That works too. So either way, with both of these, you get -1/10 or you get -0.1, same thing.
We did it with fraction.
Yeah, I mean, I probably would have put it back in decimal form just because the problem started in decimal form, just like normally if we start in one form, we try to keep it in that form, but it's not wrong to leave it as -1/10 because the directions don't require a decimal. So, all right, there was a whole bunch of people that didn't understand this one. So what are your questions if you still don't understand it?
My question is, I see what you did, but I just don't know why you did it, if that makes sense.
Are you more prone to looking at the fraction one or the decimal one? Because those are both equally viable.
The decimal.
The decimal? Yeah, so Michael, how did you figure out that it was 0.1 times 0.1? Or did you just already kind of know that?
Well, honestly, that was my first just kind of blind assumption. Like I said, just it moving just a single decimal place. And like I said, how 100 had already broke down by 10. It's still, I guess, moving in a positive direction in that, in having a negative.
Okay. So you thought like because it's moving it twice that you thought to try 0.01 times 0.01 because then that would also be moving it essentially twice?
Correct.
Okay. And then did you multiply it in your calculator to check?
Yes.
Okay. All right, cool. Did that help a little bit, Ashley?
It helped a little bit.
I'm being honest, I'm more prone to doing the fraction one. The decimal one, I think would be more difficult for me personally, but some people really see it decimals and some people really see fractions, so.
We also did like scientific notation. They could do it 10 to the -2.
Yeah, that's true. And then they could move it from there. Well, it'd be 10 to the -12 or no.
No, -2.
Oh yeah. That's right. You could also, so another way you could do it, I was thinking of the ant, never mind. Yeah, but another way you could do it is you could rewrite it as 10 to the -2 because we moved the decimal twice with what we did in the previous unit.
Yeah.
And then square root of 10 to the -12 or -2 is just 10 to the -1. -10 to the -1. which is the same as -1/10, or you could have said move the decimal back 1. So then it'd be -0.1. There's a couple ways to solve this one. Again, for me, I'm more prone to the fraction one, but you could use scientific notation, you could use decimals, you could use fractions.
Okay, the scientific notation helped me a little bit. That it kind of clicked a little bit better.
Okay, yeah, because you might see this one as 10 to the -1 times 10 to the -1. So then they are a couple and they get to go out.
Mm-hmm.
Yeah, you might see it like that. That's another way to think about it, because these get to go out. Just depends which way you prefer. Anyone else have any questions? Like I said, I know a lot of y'all skipped this one, so let me know if you have questions.
No.
No? Okay. All right, let's keep going. Sage for 23A. Are you here, Sage? Sage? Are you here, Sage? All right, next is, oh, Ashley, you're next. Group 2. So what is the square root of 19? This one says round it to the nearest hundredth. So I'm guessing you're using a calculator on this one.
Okay, because that's what I did. I was like, because at first we tried to like work it out, but then we was like, no, something's not adding up. So I did use my calculator and I rounded up to 4.36.
Okay, did others get that?
Yeah.
Okay, because I was a little
Yes,
on
because
my
that
rounding.
decimal went on for like 20 digits. Yes.
It did say in the directions to round to the hundredths, so make sure you check those directions for rounding properly.
Right.
Yeah. All
Okay.
right.
Oh, I apologize. I have a quick
Because
question.
it's like prime.
When you have to round to the nearest hundredths, you have to look at this. You have to look. Okay, has the decimal point? I mean, point decimal 3.6. I'll look at the 6, and then that will let me know if I need to go up or down.
No, you look at the number after the 6. What was the number in the actual calculator? 4.3 what?
8 after that. I remember that.
Oh,
I cleared it.
so 5.8?
Yeah,
I'm sorry, it was 4.358.
Okay.
Yes.
Yeah,
Going to
so
be
I forget what it was
0.36.
after that.
yeah, so if this is my hundredth, that's the decimal place I want. So that, keep in mind, my choices are we can stay a 5 or we can go up to a 6. Those are my choices. I look at the number to the right. This number here is the one that's telling me what I do.
Okay, gotcha. Yeah, because when I was rounding, I still was like, I'm not 100% sure if I rounded up right. So thank you
Yes, you did.
for learning that part.
You got this.
In this case, teacher is 4.36, right?
Yep, that's correct.
Yeah, thank you.
All right, next is 23B for Diana. Diana, you here?
Yeah, but I didn't really know if the first one we did was right. So
Well, do you have your calculator? Can you do
yeah,
it?
I'm doing it right now. Okay.
7.28.
I think it was 4.36.
What did you
Wait,
type?
no, wait, 7.28.
28. Yes,
We're going
28.
to 2 decimal places. Yeah.
30.
No,
So
she said it right. She said 2.8.
I thought she said 30.
She said 2.8 and then she said 30.
Oh, okay. So this one is the one we want, right? So it's either going to stay an 8 or it's going to go up to a 9. So we look at the number behind it. The 0 means we stay. So it's going to be 7.28. Okay. Cool. I don't mind reviewing rounding every once in a while because I know students sometimes forget. So it's good to go over rounding. All right, here we go. Next one, variables. Woohoo, getting more interesting. Okay, 49. That is for Vanessa.
I wasn't sure how to start this one.
Can you do the number part? What's
Would the
square root of
number part
121?
be 11?
Okay, good. And then what, remember, if we want to break it down, we can break it down. It's 11 times 11 times A times A times B times B. So if you circle the couples that get to go out, maybe that'll help kind of visualize what's happening. The couples get to go out on date night.
You mean a? We have a squared, b squared inside, right?
Yep.
Yeah, it's just a squared. Yeah.
So can you take a guess at what it would be now, Vanessa? Does that help a little bit?
So would it be the 11 on the outside
Uh-huh. And what else got to go out?
and then 1A and 1B on the outside?
Mm-hmm. Yep. And then do we write the square root after? Do we write it?
That's the part I got confused on.
Well, if there's nothing left in it, we don't really need it anymore, right? It means we've
Okay.
completed the operation, so it's done. So we don't need it anymore. There's nothing left inside. Yeah, so it's just 11 AB. All right, let's go to 55. So next is Alondra. We're in group 3 now. I see you there, Alondra.
Yeah, I was just unmuting myself.
Oh, okay.
I got 3 and then the square root 3. No,
Okay.
not square root, the that.
Yeah. So I'm guessing you broke it down into 3 times 3 times 3, right?
Yes, and then I put 2 of them together in the outside.
Okay, cool. Yeah, looks good. Any questions on that one? No? Okay, let's go to the next one. So we are at Jade. You are next for group 3. Jade, are you?
I'm here.
Okay.
Did you say number 3?
61, I said you're in room 3.
Oh, I was like, number 3. Didn't know we had that one.
No.
I got 2 squared with a remainder of 20.
Oh, okay.
Also did the decimal because I didn't know which answer y'all really preferred, but I can see the remainder would probably be best.
Yeah, if it's just a simplify, then you're gonna want to keep it in the radical form and just break it down as much as you can. So it sounds like you did, because you said 20. So you did 2 times 2 times 20. Is that what you had in your
Yeah.
radicals? Okay, can we break down 20 anymore? Does 20 have some more stuff that multiplies to
Yeah.
it?
Yes.
What could we break it down to?
I didn't even think of it, sorry.
It's okay, let's do it now. So what can 20 break down to?
10 and 2.
Okay, so 2 times 10. Does 10 break down anymore?
2 and 5.
Okay, so let me erase my 10 and I'll put a 2 and a 5 there. Okay, so now we have all prime. So circle the couples that get to go out of the house. And then the 5 is at home watching, or maybe this one's happy. Maybe it wants to be at home watching TV. So what would I get?
Well, 5's still on the inside, so would the remainder be
So what got to go out? Let's write those in front.
like it's a whole number, right?
Yeah, 2 times 2, that's the first couple that got to go out. So that's a 2 that represents that couple.
Oh, so is it gonna be 4 on the outside? Because each 2
Uh-huh.
represents a couple? Okay.
Yep. Yeah.
I have a question.
Yeah.
So the 2 times 2 times 2 times 2 times 5, is that supposed to equal 800?
It is
No.
supposed to equal 800. Does it not equal 800?
I got 80.
So originally Jade had 2 times 2 times 20. Was that not 800?
No,
Oh, so what are we
I
missing?
from the beginning.
It's okay. What are we missing then? Did we miss
Another
something?
5.
Oh, we need another 5? Let's see, 800, that's 8 and 100. 4 and 2, there's our fruit right there. 2, 2, 2. 25 and 4, 5. Oh, we do need another 5. Like I said, feel free to draw your tree, you know. Looks like we're missing a 2 and a 5 because it looks like I have 1, 2, 3, 4, 5 2s. So actually we need some more 2s.
You
I have 5 2s and 2
have
Only
this
5s.
one more two. Only one more two. If you do 2 more twos, you'll have 1600.
Yeah, one more 2. Yeah, that's why I said we have 4 and I have 5 when I counted, and now I have 2 5s. All right, so Jade, here's another opportunity for you to practice what we just did. Well, what would I circle? What goes out?
Circle 2 pairs of 2s and the pair of 5s.
Okay. So let me cross this one off. All right, so tell me what we get outside.
20 on the outside, 2 on the inside.
Okay. All right, cool. See, that time it was faster.
But I did it the fastest way. Then what are you doing there?
Oh,
That's
yeah.
That's also what I gave you originally.
Oh, really?
Yes.
I thought you said it was 2 times 2 times 20.
No, I gave you the 2 squared with the 20 on the outside.
Oh, I think that's the way you're reading it. You keep saying like squared and remainder, and those words are not any of this stuff. So I think I was confused and thought you didn't know how to do it.
Oh.
So it's square root, not remainder. We're not dividing. The remainder is when we divide, and then squared would be like an exponent. So that's squared. Yeah, so how we read this is 20 square root of 2. Or some people say 20 times the radical of radical 2. That's another way I've heard people say it. But not remainder. Remainder is like long division. We're not doing that. Yeah.
For me, teacher, this one I just did everything instead of the square, 2 power of 3 and 10 power of 2. I put outside the 2 and the 10 and
Yeah, there's
it's
definitely
the
faster.
fastest way.
No, there's definitely faster ways to do it. I'm just breaking it down for people who don't remember how to do it. There's definitely faster ways to do it. If you are familiar with it, you can do it quicker. Yeah. Because you can break it up and you can say, okay, I see that this is the square root of 400 times 2. And I know that the square root of 400 is 20. So that's 20 root 2. I mean, that's faster. It just depends how familiar you are with breaking down these numbers. All right, those are all the ones I assigned so far, correct?
Correct.
Yeah.
All right. So I definitely want to make sure that we get to some of these imaginary ones. So I think we might skip, and then if we have time, come back. Because I really want to make sure we get to the imaginary ones. So let's do, just to make sure we have time to get to them, let's do 409, 417, 423, 431, 433. So we'll start doing, oh, there's one more, 437. Start doing the imaginary ones, just so we can get that practice in. Now, when it comes to combining like terms, I is the same thing as any other variable. So if I have like 2i plus 3i, what's that going to be? 5i, yeah. Or if I have like 10i minus 7i, that's 3i. So when you're just adding and subtracting, it just behaves the same way as a regular variable. It's only that special time when we get I squared where we have to do the -1 substitution, okay? But everything else with adding, subtracting, it's just acting like a normal variable. Okay. All right, let's try it out. Square root of negative 11.
It's prime, is it not? That just kind of stays as it is.
But we
Right.
can do the square root of the negative, right? Remember, I could
Right.
break it up in a negative 1 times 11.
So that give you I times the square root of positive 11.
Yep, there you go.
Okay.
Did you happen to get to C also?
Be the same kind of principle, I guess. You'd find trying to find the square root of negative 8. You again need the I for the negative place, and square root of 8 here would be just, sorry, I got the square root of 2 times I2.
Good, yeah. So square, you said 2i square root 2?
Yes.
Yeah, good. That's the order it goes in. We put the number first, and then the I, and then if there's to 417.
Froze up there for a second, I think.
Oh, Michael, I was saying Michael L, did you get to 417? Am I still frozen? No, Michael L, are you around? Nope, Michael L's not around. Okay, next person. Let's go to Jerry. Room 4, Jerry.
We're on 417.
Yep.
That one I I rewrote it without the parentheses, so
Okay.
it's easier for me to look at it
Yeah.
because I saw parentheses and then I multiplied it first. So
Oh,
so then I rewrote it. And then I just combined like terms, so I got 8 plus 7i.
awesome. That's good to me. Any questions on that one? All right, let's go to this next. Brian.
This was what, 423.
23.
Thank you.
Yeah, 423.
So for 423, I got it down all the way to, I'm not sure if it's correct, 8 plus 5i.
Okay, did you distribute the negative? I just want to make sure.
Yes.
Okay, cool. So I'll rewrite it just in case anyone's not sure about the distribution part. And you said you got 8 plus 5i, correct?
Yes.
Okay, yep, looks good to me.
Awesome. I didn't mess up.
So notice on these problems that I'm writing the I component second. That's just how we write it traditionally in math. Traditionally, we write the real piece first, which is like the 8 and the 6, or the 8. In both cases, it's the 8. Both problems we just did. And then we write the imaginary component second. That's just like traditionally how we write it. All right, 431.
Did she freeze again?
I think yes.
Oh, now it's back. I don't know why it's being weird. My iPad's being strange right now. There we go. Okay. So, who was I at? I just had Brian help. So now I'm at Charmaine. Charmaine, did you get a chance to do this one?
I wasn't sure exactly what to do, but so I distributed the negative 6i with the -3 and -2i. And then, hold on, okay. I just want to make sure I didn't miss something. Okay, that was my bad. Okay, so then 12i.
Is that what you got when you distributed? I just wanted to make sure we got the same distribution.
Yeah. Mhm.
Okay.
Yep. And then 18 minus 12.
18i, don't forget the I. But you're right, it will turn into a subtracting 12 because I'm substituting that -1.
And then, so then it becomes 12 minus 18i because you switch them. Because of the a plus bi, right?
Mhm.
Okay.
Any questions on that one? That's the first time we've substituted that -1 we talked about at the beginning of class.
Excuse me, which is your and the results here? Is it 2 minus
-12.
9a?
It's -12 plus 18i.
I find 2 minus 9a.
I'm not sure how you got the 2 minus 9i.
Because I find 20 minus 18 plus 9.
Are you on a different problem? Are you on 433?
Yes, I mean the.
Oh, we're on 431 that we were just doing.
431, it's minus 12 plus 16i.
Yep, that's what we just said. Mhm.
Okay, sorry, I was looking
Oh,
down.
it's okay. Yeah, no problem.
Thank you.
It'd be 18.
Thanks so much.
I think she said 16.
Oh, did you say 16i? I thought you said 18.
I said 16i.
Oh, it's 18i.
Maybe it's just adding. Okay, thank you.
Yep, no problem. All right, next we have Carson. Carson, you're up.
For 432, right?
432, yep.
Oh, I think I might have skipped over this one. Uh-oh.
Well, we can work on it now.
Okay. Let me. Is this multiplication or?
Oh, I guess it's 433, not 432.
Oh, okay.
433. Sorry, I miswrote it.
Okay.
Yeah.
So
When there's, oh, go ahead.
I distributed like you would multiplication, but after doing the last couple, I feel like that's wrong.
Oh, you distribute because there's no symbol in between the parentheses. They're just touching.
Oh, okay.
That means it's multiplying.
Okay.
So we are going to multiply. So I think it's -20 from the first two. Did you get that?
Yes. Plus 24i minus 15i plus 18i squared.
Okay. Now we got to do some simplifying.
So it would be -20 plus 9i plus 18i squared.
Okay. And then based on that last problem that we just did, is there any other way we could simplify it more?
Turn the I squared into a -1.
Yep. So I'm going to erase it and right there and put parentheses -1.
And then it would be -38 plus 9i.
Yep, there you go. Cool. Okay. Any questions on that one? No? Okay, let's try 437. I am at Fernanda.
I didn't get to this one, but wouldn't you like write it twice instead of the square?
Good, yeah, usually it's helpful for students to write it twice so they can see the distribution.
Yeah. And then multiply the 3 and 3.
Okay.
And then 3 and 4,
Mm-hmm.
12. 12I.
Uh-huh. Good.
4 and 3 to 12. 4 and 4, 16. I. Oh,
So then you got 16I squared. Is that what you got?
mhm.
Cool. All right, so let's simplify it a little bit.
So you could do 12I plus 12I, 24I.
Uh-huh.
And then the plus 16, would it just stay like that?
Well, remember what we did on the last one. What can we do with the I squared?
Oh, put a -1.
Yeah, which will make that a minus 16, right?
Yeah.
So now we can combine the 9 and the minus 16.
-7.
Okay, -7.
Mm-hmm.
Okay, awesome.
Yeah.
Cool.
It's -7 plus 24A, right?
Yes.
Perfect, thank you.
I know. Thanks for checking with me. I know sometimes I don't say it out loud and I write it and I just say that looks good. So thanks for checking with me. I keep forgetting to say it out loud for you sometimes.
Thank you, because sometimes the sign or some I did it good, but the end it's thank you.
Yeah, no problem. Okay, any questions on these? How do we feel about complex numbers so far?
Doesn't seem all that complex.
That's good. That's good.
I feel pretty good about it.
Okay. All right, other people, maybe thumbs up if you feel good about it, thumbs down if you're like, I have no idea what's happening and I have questions, something like that, somewhere in that range. Okay. Jade, Leslie, I didn't see a response. Oh, okay, there you go, Leslie. Jade, okay. All right, Carson, I saw sideways. Did you have a question? Is there anything I can help with?
No, I just keep making like little mistakes.
Okay.
Yeah.
All right. Okay. Okay, so let's go back to our groups. We have about 9 minutes. We can work on some of those middle problems that we skipped. So let's go back and do some of those. So let's do, I'm gonna just assign all of them, all the middle ones, but then when we come back, we'll just get to what we get to before class ends. So 67, 71, 83, and well, 83 is A and B. I think that was all that was left. It was just those 4. So let's go back to groups.
Um, 67, 71, 83 A and B.
Yeah, it's just the last 4 that we didn't do.
In 8.2 or?
Yeah, section 8.2. We skipped them because I really wanted to make sure we had time for the complex.
Okay, all right, thank you.
No problem. Because we can here in this last couple minutes, so hopefully we can get to all of them. Let's see. I already forgot who I was at, so let me check. I was at Joshua. Joshua, can you help with the first one? Joshua, oh, there you go.
I separated it to y to the 10th times y 1.
Oh, that's a good plan.
And then for the square root of y to the 10th, I got y to the 5th, and then times the square root of y to the power of 1.
Cool. Now, if you wanted to write out all 11 y's and circle all the pairs, you can. You'll find that there's 5 pairs. So you'll get the same thing. Cool. All right, Leslie, you're at 71.
Yeah, I didn't do this one.
We'll try to do it. What's the square root of 125? Can we do the number?
So is it 25 and 5?
Okay, you want to break it down? We can totally do that. 25 and 5. 5's a prime, and then 25 breaks down into
5 and 5.
5 and 5. So it looks like we're going to have a pair of 5s probably, right?
Yes.
And 1 5 left. So I can take a 5 out. Okay. And then what about the R? I have 13 R's. So think about how many pairs that is.
So would you be left with 6?
Good. Yeah. So R to the 6 outside because there'll be 6 pairs. And then is there an R left?
Yes. So it'd just be R. 5R.
Yeah, because there was a 5 left and there was a single R left. Okay. All right. Now I've gone through everybody except Michael L. because you stepped away when I called your name. So Michael, can you help with 83A? Did you get to that one?
No, I didn't.
All
I'm
right.
just looking at it right now.
Okay. Could you, we can't do anything with the 5 plus, but can you do the square root of 12?
Give me a second.
I can do a tree if that helps.
So, I'm not really sure. 5 plus this.
So when I did the tree, I got 2 times 2 times 3. So I can circle the
And then you
2.
have a pair of 2.
Good. So 5 plus, what will it be?
I'm not sure.
Well, we're taking the pairs of 2s out. So what do I write out front?
Oh, it's the square root of 3?
2 square root of 3. Yeah, because the 2 that's out front represents that couple that's out on the date. And the 3 is the person in the house.
Oh, I see where you're at.
Yeah.
Okay.
All right. Okay. So I guess we didn't have time for 83B, but you can check that answer in the back of the book in the answers because we got to let you go.
And
But we got almost all of them. Huh?
They should have their test grades back for test 4.
Yep, that's true. All your tests have been graded. They should be back. If you do want to meet with me at some point, let me know. And I can put in fake scores for you for the next few tests to see what you need to pass if you're not passing. Okay. All right. We'll see
Hey,
you
thank you.
tomorrow.
Have a good day, everybody.